Okay, so these are the notes for Math 113, and you'll notice we're doing a little bit of review before we actually start Chapter 8, which is going to be our first chapter that is going to be covered in the course. We're going to do B1, B4 right now, and then before Chapter 9, I believe we're going to do B5. So these are going to be reviews, so we'll go rather quickly through these. You'll still have homework on them though. So B1 is just solving all different kinds of equations, and you know from your other courses there are all different kinds of equations to solve. So I just have a bunch of different examples that we're going to do to help you review. So first of all, the steps that you need to go through when you are solving equations. Step 1 is you will always eliminate any parentheses by using your distributive property. Step 2, if there are fractions, you'll multiply everything through by the lowest common denominator of all of the fractions, and that will eliminate the fractions for you. Step 3, you look on both the left and the right hand side of the equal sign, and you combine any like terms that's possible. Step 4, you're going to use your addition and subtraction properties to get all the terms that contain a variable to one side of the equal sign, and all the terms that don't contain a variable to the other side of the equal sign. And then step 5, you'll finish off by either multiplying or dividing both sides of the equation by a value to help you get the variable alone or isolate the variable. So they're going to get more difficult as we go on with our examples. Let me zoom in a little bit here for you. Okay, so for 1a, you can see that there are no parentheses or no fractions. So step 1 and step 2 are all done. Step 3 is actually done. There are no like terms on the left-hand side of the equal sign, as well as no left or like terms on the right-hand side of the equal sign. So basically we're at step 4, where we have to gather everything with a variable to one side and everything without a variable to the other side. So you can see everything with the variables already on the left. So we want to move this positive 5. So we're going to subtract 5 from both sides of the equal sign. Remember equations 101, what you do to one side of the equal sign, you always have to do to the other side of the equal sign. So that's going to give me negative 3x. Those are going to cancel, is equal to 23 minus 5 is 18. And now we're going to go ahead and isolate the x by dividing both sides by negative 3. And you're going to get an answer of x equals negative 6. Now, if we look at B, you see that there are parentheses. So the first thing we want to do is eliminate those parentheses by using our distributive properties. So our 3 gets multiplied by both things inside the parentheses. So we would have 3y plus 3 times 5 is 15 is equal to 8y. Now we want to go ahead and we want to get all of our variables to one side. So as you can see, we have variables on both sides of the equal sign. So let's go ahead and let's subtract 3y from both sides of the equal sign. That's going to cancel there and leave me with just 15 on the left-hand side, and then 8y minus 3y is 5y on the right-hand side. Let's isolate the variable by dividing both sides by 5, and we'll get an answer of y equals 3. If we go to C, you can see again we have parentheses, so we need to get rid of those by distributing, remembering that there's really a negative 1 in front of those that set of parentheses. So we'll have 5y minus 2y. Now be careful, negative 1 times negative 10 is plus 10 is equal to 25. Now you can see we do have some like terms that we can combine on the left-hand side. So we have 5y minus 2y is 3y plus 10 equals 25. Now all my variables are on the left, so we're going to take and we're going to subtract 10 from both sides, which will give me 3y is equal to 25 minus 10 is 15. And isolate the y by dividing both sides by 3, and you can see we're going to get y is equal to 5. Remember, you can pause or stop this video and rewind anytime you need to if you need to see a problem again. So D is our first problem that has fractions. So what we want to do is we want to multiply every term in the equation by the LCD of all of the fractions, and that will help us get rid of the fractions. So we can see that the denominators are 5, 10, and 5. So we're going to multiply everything through by 10. And I like to write it as 10 over 1. So 1/5 times 10. So the 5 would cancel into the 10, giving me 2. Plus, if I multiply 3/10 times 10, the 10s are going to cancel. And I'd have 3x is equal to, here the 5 cancels into the 10, giving me a 2. And 4 times 2 is 8. Voila, no fractions. Now it's just time to start moving things around. Since my variables are on the left, I'm going to subtract 2 from both sides. And that's going to leave me with 3x is equal to 6. And then isolate the x by dividing both sides by 3. And you can see we're going to get x equals 2. Now E combines a lot. In fact, all of our steps. So notice it says to get rid of the parentheses first before you get rid of any fractions. And that's something that you're going to want to make sure you're going to do. So we're going to do our distributing. And as you can see, we have 2 different places where we have to distribute. So 2/3 times x is 2/3 x minus, now this is really over 1. So if I multiply straight across, you can see I'm going to get 4/3 minus 1 equals, let's distribute through the 1/4. So we'd have 1/4 x minus, this is really over 1. So 1/4 times 3 over 1 is 3/4. Okay, so now we want to get rid of all the fractions. Well, we have denominators of 3 and 4, which means we're going to multiply everything through by 12. Okay, so if we do this first term, you can see the 3 cancels into the 4, giving me a 4 times 2 would be 8x minus, here the 3 cancels into the 12, leaving me with 4 times the 4 is 16 minus 12 times 1 is, of course, 12, is equal to 12 times 1/4 would be 3 times x minus, here again, the 4 will cancel into the 12, leaving me with 3, and 3 times 3 is 9. Voila, no fractions. We have some like terms that we can combine, so let's go ahead and do that. I can see I'm going to have a space issue already. So I'm going to get all my variables to the left, so I'm going to subtract 3x from both sides. So I'm going to get 5x minus 28 is equal to -9. I'm going to add 28 to both sides, and I'm going to fly up here. So that's leaving me 5x equals, and -9 plus 28 is going to be, oh boy, what, 19? And if I divide by 5, you can see it's my first answer that's a fraction. I'm going to go ahead and I'm going to get 19 over 5. And you can just leave it as 19 over 5. Don't give me a decimal. The only time you should give me a decimal as an answer is if there was something that was a decimal in the original problem. Otherwise, leave it as an improper fraction. All right, well, let's see what's going to happen here. Again, I'm seeing some distributing going on. So we do 2 plus 9x equals, here's the distributing, 12x plus 3 minus 1. Let's combine some like terms on the right-hand side. 3 minus 1 is plus 2. Okay, so we notice we have variables on both sides of the equal sign. So I'm going to go ahead and I'm going to subtract 12x from both sides. Now you may do things in a slightly different order from this point on, but that's okay. So 9x minus 12x is negative 3x. Now, since all my variables are on the left, I'm going to go ahead and I'm going to subtract 2 to get everything without a variable to the right. So those are going to cancel, and we'll have negative 3x is equal to 2 minus 2 is 0. Don't panic with that 0. That's okay, because now I'm just going to get the x alone by dividing both sides by negative 3. 0 divided by anything is 0. 0 can be an answer. That's okay. All right, let's go ahead and do G. Again, we've got a lot of different things to do. Notice how we have two sets of grouping symbols here. We have these parentheses and we have these brackets. So the idea is you want to work from the inside out. So we're going to do this distribution first. So we'd have 2 times brackets, 9. I'm going to distribute my negative 3 through. So negative 3 times negative 2x is plus 6x plus 12 equals 12x plus 42. Let's combine our like terms inside the brackets, and I'm looking at 6x plus 9 plus 12 is what, 21? Now we're going to get rid of this set of brackets by, again, distributing. If I distribute here, I'm going to get 12x plus 42. And at this point, you should see, something interesting is happening. So, for example, if I say, hey, I'm going to get all my variables to the left-hand side, so I'm going to subtract 12x from both sides. Well, what happens? All of your variables will drop out. So there are 2 possibilities when all of your variables drop out. One possibility is what's just happened right here. Our variables dropped out and we ended up with a true statement. 42 does equal 42. What that means is that all values of x, any values of x you plug in, are going to work. Any value of x is a solution. So one way of thinking about that is all real numbers, but we want to write that in a slightly more mathematical way. So here's how we're going to write it. It's the set, so it should be in set brackets, of all values of x, and then you write a little vertical line segment. In math, that is read such that x is n, this symbol, this means is an element of capital R, which is the real numbers. So what this says in math is these solutions are all x, such that x is an element of the real numbers. In other words, all real numbers. This is just a more mathematical way of putting it. So this is our solution for this problem. But let's talk about what happens if your variables drop out and you don't end up with a true statement like here. You end up with a false statement, like maybe you would get 20 equals 42. Well, we all know that that's not true. If that happens, that just means your answer is no solution. So in other words, there is no value of x that I can plug into this equation that would make that equation into a true statement. And for that, all you have to do is write no solution, or you could write the empty set, which would be kind of, I don't want to write it in your notes, but it would be kind of like that. And I would accept either one.